class, here is the last section of chapter 9. We are going to do a little more detailed look at dilations today. We looked at them a little bit before, and now we're just going into a different aspect. So a dilation with a center C and a positive scale factor, they're going to use the variable k for that scale factor, where it's saying k is not equal to 1. If k was equal to 1, it'd be the same size. So this is either going to be getting smaller or larger, just like before, is a function that maps p to a figure, in a figure, to its image, such that we have two scenarios. If p and c are coincident, then what that means is that they are going to be the same point. So we can write down that the image and the pre-image are the same point. In other words, it's not moving at all. And if P is not the center of the dilation, then P prime lies on the line CP, and we can say that the scale factor is equal to the center to the image over the center to the pre-image. And if you want to maybe write down that this is the image over the pre-image, I know when we did this before, some students had a hard time kind of remembering which one was which. Again, if you have that hard time, you could always see if k is more than 1, it'd be an enlargement. I'll write that down here. If k is greater than 1, it's an enlargement. And if k is less than 1, it's a reduction. So if you ever forget which way it's supposed to go, that might help you out. So looking at this example here, we can see that here is the center of the dilation. We see that all of these points are not on that. So here is L. If you connect that line, L prime will be on that line, and the ratio here will be whatever the scale factor is. So it says that the scale factor is 2 to 5. Looking at like these distances, especially on this side, that one doesn't give us any distances, but C to P is 4. If I then multiply that 4 by 2.5, you can see that the whole distance here would be 10. Or again, if you divided for the scale factor, C to P prime divided by C to P, meaning the distance from a point to a point on the image, that's 10. And then to the pre-image is 4. If you were to divide those, you would get 2.5. So we'll do some examples, and if it's not clear now, maybe after the examples, it'll become clear. Questions here say we need to determine if it is an enlargement or reduction. So just look and see, is it getting bigger or smaller? And then we're also going to have to tell what the scale factor is and solve for x. So the solving for x is probably one of the easier things you're going to do. Like here it says that this whole thing is 7 and this part is 5. So solving for x, x would just be 2. This is k and this one is k prime, so it's getting bigger. This is an enlargement. You can say that x equals 2, and I always like to find x first and then tell what the scale factor is. I'll use k for scale factor, but if you'd rather write out the words, that's fine. So make sure that when you're doing this, you're going from the center to the image over the center to the pre-image, and I'll just label this point here as the center of my dilation. So the center to the image, that distance is 7, and the center to the pre-image, that distance is 2. So if you want to leave it as 7 over 2, that would be fine. If you'd rather change this, it would be appropriate. If you want to change it to say 3.5, that's okay also. Okay, so for this one here, here is k and here is k prime. This is a reduction, it's getting smaller. X would be 3 because the whole thing is 5 and this part is 2. And then for the scale factor, it's the distance from the center to the image. So in this case, it's 2. And then the center to the pre-image. So in this case, that is 5. And we can see here that this is a reduction, that scale factor is less than 1. This one being an enlargement, that scale factor is more than 1. I would memorize, if I were you, that it's the center to the image, and that'll be the one that has that prime, and then the center to the pre-image. And you know, like the example has like C to P or C to P prime. This one would be like C to K prime. Doesn't matter what that letter is or what that center point is. Center to the image, center to the pre-image. So when we're doing these dilations in a coordinate plane, I think you'll like these. Dilations in a coordinate plane, what's happening to that is you're just taking a coordinate point and you are multiplying each part by whatever the scale factor is. So I'll just write multiply both x and y by the scale factor. So when we're doing these, I think I need to scroll down. What I could do is I could look at, I don't know why they use R here, but the R is the scale factor if you'd rather change that to K. You're going to multiply each part of that coordinate by that scale factor. So 4 times a half, or you think of this as like dividing by 2, multiplying by half, and 8 times a half is 4. 8, when you multiply each part of that by a half, you get 4. And P prime will be at 3, 2. Again, just multiplying each of those parts by a half. I would like you to draw both of these. So draw the original and draw the reduction in this case, just so we can see what's happening. If you want to pause it and draw it, and then just check your work when we're done, I'll just fast forward and just have the answer up in a second. Okay, so this is your reduction. The reason why I actually wanted you to draw those up is so that I can show you. It said here, I didn't really read this, but it's centered at the origin. And again, what that means is you can take that line and it should kind of extend through. Each of these points are half the distance that they originally were. So just kind of a way to tie these things together. We have to use like distance formula to find the distance of those, but the center to the image is going to be half the center to the pre-image. Same thing for this last one. If you want to just try it all on your own, that's fine. I'll go through it, but if you want to do it on your own, then fast forward to the end. That would be okay with me. So what you got to do first is you need to multiply each of those by the scale factor 1.5. So that's going to put D prime at -3, 0. G prime will be at 0, 3. And F prime will be at 3, -3. So go ahead and take a minute to graph those and then come on back and check your work. So to wrap this up, here's how this last one would look. It is 1.5 times the distance from the origin to that point. And here you can see that the origin is kind of on the middle, so that dilation is just kind of like it's expanding from that point versus when the center is not inside of that. So I hope this helps. We'll practice this in class and take the test soon.